Everyone. Last video we have discussed about the spring element problem. In this video we are going to see about the one-dimensional elements of structural objects. So here we are consideration bar and beam elements are consideration one-dimensional elements. These elements are often used as a model of truss and frame structure. In general, the one-dimensional elements will be classified as either bar or beam. That will be classified as based on the loading condition. This bar and beam will be finally consideration truss and frame structures. So here how the real-time structure will be converted into a finite element model. So first diagram will be a real-time structure. It has an three-dimensional objects. They're having a thickness and area, and then they're having a constraint and force. The real-time structure will be converted into a 2D model. So it is a converging model. So that will be converted into a desired shape for applying areas. Next, the finite element model, finite element structures. We are converting into a 2D model into a finite element structure. So in this we are considering step bars and constraint forces. Then finally we will convert as a finite element model. It will be in just a single line for a primary input data, and then the secondary input data will be given as an area. So that will be consideration one-dimensional element. And then element conversations. So these are the actual models. And the next one is a finite element expression. What the secondary inputs are given. For example, rods and beams for any cylindrical objects will be acting as a difference on the loads, and then sections that will be consideration 1D. So in this previous video itself we can discuss about the how we classify as 1D, 2D, 3D. So based on that, the rods and beams will be consideration 1D. The finite element expression, geometrical difference, will be in a straight line. So only length will be considered. The secondary parameter will be an area. So then only we can consideration volume. So length into area. So length is in primary inputs, and then area will be in secondary input. For 2D, we are consideration cell, plane stress, plane strain, axisymmetric elements, etc. Here the area will be consideration primary input. The secondary inputs will be in thickness. So the area into thickness will be in volume. And then three-dimensional objects, the 3 dimensions will be consideration primary inputs. So the volume will be consideration primary inputs. There is no secondary inputs. So this is the element conversion for real-time object to the finite element model, and then secondary parameters. So here bar element. Bar is a member which resists only a axial load. While the axial load is applying for any structure, that will be consideration bar element. So first one, they're having a 3 stepped bars. So minimum we want to create as an 3 different elements. So in previous videos we can discuss about the factors affecting the discretization process. There we are mentioning as an geometry can influencing for discretization process. So based on that, here they're having a 3 stepped bars. So 3 different areas. So for that minimum we want to create as an 3 elements in a straight line manner. The second one will be an same objects, same size. So that will be consideration different elements. So it depends upon our convenient. We can able to convert it in single elements or multiple elements. This is the trusses. A truss is an assemblage of bar with a pin joints, and a frame is assembling of a beam of elements. So trusses means either it will be a bar will be connected by using a pin joints, or frame will be connected by using of an beam elements. Either it wants to connected within pin joints or riveted joints. Here this is the real-time structure. They're having a 2 members. One will be horizontal of 2 meter. Another one supports will be connected within inclined of 1.5 meter. The force acting it in hinges. So that will be converted into a finite element model. So thank you for watching this video. Next we will see in another